Hello everyone. Welcome to the next video on converter design, DC to DC converter design. In this numerical, we are going to design a boost converter. In this boost converter, let me take a different color pen. Okay. So we have to design a 50 volt DC supply is connected to a 700 watt 100 volt supply. Means in this problem, the source voltage is given as 100, source voltage is given as 75 volt. Okay, let me correct 75 volt. And the output voltage is given as 100 volt. Whereas the output power in this problem is given as 750 watt. So we have to design the boost converter because we want to step up the voltage. So hence it is a boost converter with the following specification. The ripple in the inductor current is limited to 10% of output current. So here delta IL is 10% of your output current, that is I0, and voltage across ripple, that is delta VC is the 2% of the output voltage V0. It is given. So, and the switching frequency is 75 kilohertz of the switch is given. We have to determine the rating of the inductor, capacitor, switch, and diode. Also draw the circuit diagram with showing all the ratings. So how to determine the duty cycle in the boost converter? So in the boost converter, duty cycle is defined as V0 minus Vs upon V0, or you can utilize this formula 1 minus Vs by V0. This is also okay formula. So how it is, this formula is arrived because duty cycle is T on by T off. So T on by T off. So from this form T on by T, from this T on by T, this formula is determined here. It is Vs upon V0, 1 minus Vs upon V0. So in this case, the Vs is equal to V0 is equal to 100 volt, and Vs is equal to, sorry, the Vs is not 75, it is a 50 volt. This is my major mistake, so please correct it. It is a 50 volt. So 50 volt is the Vs divided by 100. So its duty cycle comes to the zero point 0.5, or you can say it is a 50%. Now let us determine the load current. So see here, the load power is the 750 watt on 100 volt. So how to calculate the current I0 here? So the current I0 is nothing but P0 upon V0. So which is determined here. It is a P0 upon V0. So 700 by 100, it comes to 7 ampere. Okay, let's go for a next calculation. Then we have to determine the inductor current. Okay, so how to determine the inductor current? So formula for inductor current in the boost converter is what? It is the output current divided by 1 minus D. So output current is 7 ampere divided by 1 minus D, that is 1 minus 0.5. It comes to 14 ampere. Now we want to determine the ripple current in inductor. In the problem specification, the ripple current is given as the 10% of I0, that is 0.1 of 7. It comes to 0.7 ampere. Now, how to determine the inductor rating? So first we'll determine the inductor. The inductor is equal to Vs into D upon Fs into delta L. Vs, that is the source voltage, is 50 volt, and the duty cycle is the zero point 0.5. Frequency is given as a 75 kilohertz. So I'm keeping the frequencies in K. So if you keep the frequency in kilo, answer will become in the millihenry. Okay. So 1 upon K is a milli into delta IL. Delta IL is determined here. So delta IL is substituted here. So it is a 0.7. So it comes to 0.4762 millihenry, or you can say it is a 476.2 microhenry. Okay, so likewise, we can calculate it. Now let us calculate the capacitor voltage. So what is the voltage output ripple in the capacitor voltage given is a 2% of V0. So 0.02 of 100, 100 is a V0. So it comes to 2 volts. So maximum 2 volt ripple is allowed across the capacitor. So from that, the capacitance value is equal to I0 into D, Fs into delta Vc. So I0 is a 7 ampere, D is the duty cycle is a 0.5, 75 kilohertz, and it is of delta Vc is of 2 volt. Again, we are keeping the frequencies in kilo, hence the answer will come in the milli format. So it comes to 0.02333, that is 23.33 microfarad is the capacitance requirement. So let me write down the answers in the Okay, so let me write down the answers here. So here the value of the inductor which you got, it is 476.2 microhenry with the current in this current. What is the value of the current? The current will be the inductor current is 14 ampere plus the peak current is how much? It is the delta IL divided by 2, that is 0.7 by 2. So it comes to 14.35 ampere is the value of the inductor current. Now capacitor which we have determined, the value of the capacitor you got, it is 23.33 microfarad. So it is a 23.3 microfarad. And what is the voltage rating of this capacitor? The voltage rating of this capacitor is equal to 100 plus delta VC by 2, that is 2 by 1. So it comes to 101 volt. So we have determined the inductor rating and capacitor rating. Now see the MOSFET rating. MOSFET is equal to V0 into delta VC upon 2. So delta VC is 2, 2 by 2 is 1 volt, V0 is equal to 100 volt. So it comes to the 101 volt. So voltage across switch must be greater than 101 volt, and the switch current to the switch is equal to IL plus delta IL by 2. So IL is the 14 ampere plus delta IL is a 0.7 by 2, it is 0.35, so it comes to 14.35 ampere. So current through the switch must be rating of the switch must be greater than 14.35 ampere. Now same the calculations for a diode. V0 is equal to VD is equal to V0 plus delta VC by 2. So the voltage across diode is maximum voltage is 101 volt. So diode rating must be greater than that. And the current maximum current through the diode is IL plus delta IL by 2, which is 14.35 ampere. So your current rating of the diode must be greater than that. Okay, so by this way we can design the boost converter. Hope you like this problem. If you like this problem, please subscribe my channel and share with your friends. Thank you, thank you, thank you.